All right, today we're talking about Mitsubishi two-pipe heat recovery systems. I'm actually pretty excited, more excited than I was when I got my AI tracking camera. Let's focus here, though. You guys are here because we don't ever talk about Mitsubishi. Everything is Daikin, 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 Daikin. And I tell you right now, it's really boring just servicing one brand. But here at Kalos, we service all brands, whether that be Hitachi, LG, Samsung, Gree, Hisense, all the way to Mitsubishi. Thank you for sending this in, by the way. This data was a lot of fun. So, the difficulty here with being a VRF technician, servicing multiple brands, is getting used to the differences in programs. As you can see here, this is basically the maintenance tool for VRF when it comes to Mitsubishi equipment, whether it's heat pump or heat recovery. You can kind of see here, we've got our outdoor data. We've got our other outdoor data, right? 2 modules. More information, more information, more information, and it's kind of a little confusing between the addresses, between what the indoor units are doing. The nice thing is we can drag and drop these around as we see fit. Maybe we want to make it bigger. There's a lot of ins and outs on this program that we're not really going to get into today because this isn't about what exactly we are, how to use this program, but more so about what is going on with this piece of equipment. Right? That's what this video is all about. That's what these videos usually all are about. Finding a problem that is difficult to find. Now, we can go here in these different functions, which I actually kind of really like this program. I'm not going to lie. The questions it asks me to be able to populate all the fun things across the board here, whether it's sensors and sensor data and how it looks, and different modules and scrolling between everything. And all the timestamps here. It's really cool. But that's not the best part. Let me show you the best part. The best part is this right here, this manifesto. Yes, that is right. Live refrigerant piping diagrams on a service tool. What? That's right. You can see it. I mean, we can see which way the refrigerant's flowing now. Remember, refrigerant flow diagrams, it's a give and a take here. The give part is that they give us the flow. They show us where it should be. However, the take part is that you can't always trust the animation as to what it's doing. So yes, look at the flow, look where things should be going. But remember that you always have to question things. You're here for a reason. And that reason is the unit doesn't work, whether it's heating, cooling, parallel operation. Either way, it's something you have to investigate. So don't solely rely on the colors in the animations. Although they're fun, they help you learn, they help you connect the dots between the two. You do still have to ask the question, why is that temperature? Or what temperature should it be? Or what range should it be? Don't just assume that because it's red, it's supposed to be hot gas. Well, what if it's red and it's supposed to be hot gas and it's 32 degrees? Well, that's the question we have to ask and say, hey, red flag here. So enough about the program and the cool things that we found here. I actually watched this for a good hour today. It's really interesting. It's a lot of fun. So here you can see that I can actually scroll between the 2 outdoor units up and down. It doesn't really fit my screen 100%, but that's okay. But it's cool that it like reconnects the pipes as I scroll. And that's right, we have branch collector box information. What? Watch out. Now, I have been in this program more than once. However, I'm still going to call out the cool features that I love about this program. So you've got your branch collector boxes, but then we can also scroll away to the right and see our indoor units. I can move my big old head here so you can see a little bit better. These are all my indoor units. And as you can see here, we've got quite an assortment, actually 9 total indoor units on the system. But what is the complaint? Why am I being sent this data? Why am I making this video? The complaint is a lack of heat. Right. In Missouri right now, I'm sure it's fairly cold. I know that it's really cold here in Florida. But this time of the year, most systems are going to be switching over from cooling to parallel operation or all the way to 100% heating. And in going into 100% heating, there are some things that happen that don't normally happen, right? Especially on this VRF system. We've got a lot of 4-way valves that are shifting. We've got charges that are starting to be shifted in the system and they're going to different directions. Now the indoor units are becoming heat exchangers and the outdoor units are becoming in an evaporative state. And so all these things that are taking place in a system can start to cause problems if components have failed in a specific mode, whether that's cooling or heating. Now we're going to start to see those changes, and that always sometimes brings issues like this one here, where we do have an issue. So let's look at the data. Well, what do we see about this? Now, you can see the animation, and it's not live playing the data because none of these sensors are changing, and these designations may be foreign to you if you've never looked at this. Maybe you're very familiar with Mitsubishi, and it's just foreign to me. But at the top right-hand side here, I can actually scroll through the data points on how this system is operating and watch these temperatures as they change. It is set to Fahrenheit right now. And so this top left unit is my master unit, and this bottom left unit is my subunit. So lack of heating. Okay, so where's my mind going to go? Maybe it's going to go to charge. Well, what do we know about the troubleshooting triangle that I've been teaching about and talking about for almost 3 years now? Well, we know that we can check what? Discharge superheat, suction superheat, system subcooling. That's not universal that's not specific to Daikin. That's universal for all refrigeration equipment. So let's look at that, right? So here we have TH4, which is our discharge temp off our compressor. So that's 192. So then I'd come up here and I'd look at, okay, what's my TC? And now I get to break out my fun pen, right? Your TC and your TE are up here at the top left-hand side. So my TC is 72. That's actually really low for heat. That's really poor heating output. And so if I'm 192 over 72, well, that's clearly over 100 discharge superheat. That's not good. What about my other module? Well, my other module, I exit out of my marker here and scroll. You can see here, it shows 133. Wow, significantly lower. Now, your mind may shift and say, okay, well, maybe it's just low on oil, Roman. What if that's the case? Well, let's not jump ahead here. Let's get our 3 corners of the triangle. So we got discharge superheat. Now let's try looking at suction superheat. Well, so if we go to this module here, 32.9, TE is negative 3.2, which isn't uncommon. Negative temperatures, right? Negative Fahrenheit just means the pressure is very low and it's probably cold outside or heating. And here on TH7, we can see that it's 33.6. So it's not freezing, but it's pretty close. So with that, 32.9 degrees here, close to ambient, which is a little concerning if this is an evaporator. And that means that we're what? We're clearly over 30 degrees suction superheat. So it's starved for refrigerant, right? High discharge superheat, high suction superheat. It's not getting enough refrigerant. I'm not saying it's low charge, just saying this compressor specifically is not getting enough refrigerant. What about my other compressor? Well, the other compressor is low discharge superheat, right? And I would say low, maybe it's in the 50 range, but it's still lower drastically than our master module. So then let's look at what's the suction superheat. Negative 0.8. Well, if I'm negative 3.3 is my TE, then my suction superheat is only 2 degrees, if that, on my submodule. Well, that's not good, right? We know that anything under 5 is starting to raise the flag of alarm. I've got liquid coming back to my submodule, okay? So lack of heat. We know what now? We know the master module is not getting enough vapor to the compressor. We know that the submodule is getting too much refrigerant to the compressor. Okay, those are 2 things that we clearly spelled out by completing the triangle. Now, we haven't finished it yet because we don't have subcooling. Well, what would subcooling be? Well, on this piece of equipment, I'll be honest with you, I wish there was more temperature sensors. So Mitsubishi, if you're watching this and you want to go back and remake an entire series and make a bunch of changes based upon this video, I won't hold it against you. I'll actually praise you for that. But because they're not going to do that and nobody's going to listen or even watch this video for the most part, we're just going to jump ahead where we actually show you where we're measuring subcooling. Now, remember that I don't want to measure it after the box because remember, we've got some subcooling magic going on here in these HIC plate-to-plate heat exchangers in the box itself. So more so, maybe I want to go to my indoor units and see what kind of refrigerant output I have through these units, right? That's turning this into a liquid, right? So we have hot gas that's coming in, we have liquid that's coming out, and then that is being fed all the way across to my my outdoor system, right? Let's stay focused here on what we've got going on. And so with that, we can see here it's 111 hot gas coming in, and then leaving, right, is 68.2 degrees. Now that's a heck of a delta, or as you would think, a heck of a subcooling, when that could just be a matter of maybe there's a giant pressure drop across here, maybe there's not enough refrigerant flowing through this, which is clearly the case here. And the same thing here, 95 in, 68 out. Remember, the complaint was what? The complaint was a lack of heat, right? So if there is a lack of heat, then I would expect to see what? High delta temperatures across the indoor heat exchanger. Now, this isn't superheat, this is subcool. And if we look at what my TC is, remember 72, that's my measuring stick. So if that's the bottom of the threshold and I'm at 68 degrees, there's what, 4 degrees subcooling here. There's about 3 degrees subcooling here. There's 2 degrees subcooling here. So that's probably 3 degrees subcooling there. About 2 degrees subcooling here, 2 degrees subcooling here, 2 degrees subcooling here, 2 degrees, so 3 degrees, 2 degrees, 1 degree, 2 degree, 3 degree, blah, 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 blah. You get the gist of it. So the premise here is through all my indoor units, it's pretty consistent, and that consistency is low subcooling. So high discharge superheat, high suction superheat, low subcooling, almost got me there saying high. means that it looks like it's undercharged, but that only pertains to the master module. What's going on in the submodule? Well, the submodule doesn't reflect the same thing. If it did, then maybe we'd start to hang our hat on charge discrepancies or even low charge. But let's keep this train a rolling here. So we're making liquid on our indoor units, hopefully, and we're rolling back to the outdoor unit, right? And we did make liquid because remember, we know what our TC is, our measuring stick here, 72.5. Making that liquid, it's coming back to my box, and let's take a gander here as to what that liquid is doing. Well, we're L3, looks like an electronic expansion valve. Pretty sure it's electronic expansion valve. It's looking like it is, in fact, 3,000 pulses open, so wide open. We also see here with this liquid coming back here, we've got 258 pulses, which looks like that bypasses the box itself. That comes up and across here. That looks like that's making vapor to come back here, or maybe going through dual subcoolers to feed back over here. These colors do get a little confusing, not understanding the magic that is Mitsubishi, but I'm sure someone will easily point that out in the comments on this video. But for the most part, we know that what we're making liquid to go where? To go back to the outdoor unit to do what? Well, to turn into a vapor for our compressors. We know one unit needs it. We know the other unit has way too much of it. So sure, it's a little concerning. Now, the L4 here, the 258, looks like we are slowing down the liquid refrigerant that's flowing back before we dump it into the line and running it through our subcoolers as needed to create some of that subcooling effect, or what looks like we're trying to change that to a vapor. So going back to the outdoor unit. Let's not get hung up here, right, on the magic, again, that is Mitsubishi. Let's focus on the problem, right? We could sit here and say, well, what the hell is going on in this box, and why does it matter, and which way is it flowing, and what is it trying to tell us, and all these temperatures, and 28.9 degrees, but I thought it's 88 over here, and how is it 49 there, and what the heck is going on? Focus on what we know. We know high suction superheat, high discharge superheat in the master module. We know we have low subcooling across all indoor units at low valve pulse, and the submodule is flooding. So let's go to the submodule and show it some love. Why are you flooding submodule? Wish we could ask, but we wouldn't get an answer. But there are things here that are red flags. The red flags is the discharge superheat is low. Well, if I go and I see how does it float over time? Well, we notice it changes states, but then it goes back again, going, and it stays pretty much the same for most of this. But one thing we'll notice here, and this one's a very difficult one, in my opinion, to catch without a little bit of help and understanding and oversight, is that between these two compressors, we know they should be doing identical things, right? They're both in 100% heating mode, which means that they're both in an evaporative state, both upper and lower heat exchangers. For both of these systems, they're both in the same environment, close to the same ambient temperatures, right? Fan is running at the same speeds. They're doing the same exact thing. So why do they look so different? Why is it that my TE is negative 4.5, but yet I've only got a 1, if not less than that, degree superheat? We know that this low superheat is probably causing our low discharge superheat. And this system over here on this side is acting as if what? It's overcharged. But yet my master module looks like it's undercharged. And my indoor units are starved for hot gas because they need more. They look like they have low subcooling, which tells me that, again, they're not getting enough refrigerant to the indoor units. So why is it that all my indoor units look starved and my outdoor unit looks starved, but my submodule does not look starved? Well, that is because of a common issue with this equipment, come to find out. Four-way valves. Well, think about four-way valves, and they're designed to do what? They're designed to shift the flow of refrigerant to one side or the other, right? To redirect flow of refrigerant in a system. Well, what happens when these four-way valves fail? Well, so for this one here, if this is actually turning left, and that connects over here to the right, then we would follow that flow of refrigerant and say, okay, well, if I was dumping hot gas here, what would that look like? Well, it would go from here, it would go from here, try to go that way, maybe it can't go that way, those pulses are low, it would go through here, and it would show up what? It would show up here on this sensor. Well, this is the reason that I have a complaint. The complaint is not enough temperature sensors in the system to troubleshoot this. However, understanding how refrigerant operates and that the submodule being flooded and flooding, that this is where I'm going to spend most of my time investigating the problem. More so, well, we know that if this one floods here and goes this way, then I'm going to have what? I'm going to have a leaving coil temperature close to TC, right? Because it's creating subcooled liquid when you send hot gas to an outdoor heat exchanger in 32-degree ambience. However, what happens when this four-way valve fails? Well, if this four-way valve fails, it's going to what? It's going to go through the lower heat exchanger. It's going to go back around again through the expansion valve. It's going to go back this way, and it's going to go through the meter device, back through the heat exchanger into a vapor, back over to the actual accumulator, back to the compressor. Why is that important to understand? Well, because in this module, this four-way valve has actually failed. And how do we know that? Well, because not only do we know that because of one, this temperature isn't at TC, but two, right? We had a technician go to site and I gave him the advice of checking that four-way valve, and lo and behold, he found it wrong. He found it not shifted the way it's supposed to. This four-way valve is stuck in cooling. So what happens here? Well, when this turns over and it floods this with hot gas at 32 degrees outside with the fan at full tilt, it turns into a liquid receiver. Well, what do you mean? Well, I mean that if this coffee cup here is your outdoor heat exchanger and you send hot gas to it at a 32-degree ambient and I'm blowing a giant fan across it, again, it's basically in a freezer, it's going to turn all that hot gas into what? It's going to turn it into liquid. And what's going to happen? It's going to slowly fill up the outdoor heat exchanger full of liquid. Well, what happens when you take an outdoor heat exchanger and you fill it full of liquid? Well, now it's just a giant 410A tank attached to the unit on the outdoor section. So what's happening here? Explain a little bit more to me. So if that becomes a liquid receiver, right, we're stacking all of our liquid in the lower heat exchanger on this unit. Well, now we're sucking up charge like a sponge. Now I'm pulling refrigerant from all the indoor units over here. I'm pulling refrigerant from the unit to the left of here. I'm doing all of that naturally because, again, it's freezing cold over here and I'm stacking liquid. So I've stacked so much liquid in this lower heat exchanger that now maybe I've pulled 50% of the charge out of the system, right? It's not circulating through the system like it's supposed to. So it's stacking in the sub module. Now my system looks like what? Well, it looks like low charge, but not everywhere. It looks like low charge on the master module where there is no problem. It looks like low charge on all the indoor units and the branch collector box. However, the sub module where it's stacked so much liquid that it doesn't know what to do with it is literally flooding on the lower heat exchanger, right? Look at the superheat. We're coming up across here and we're coming back here. It's 2.3 degrees and now it's negative 5.2. Right, so it looks like we have superheat here, but the problem is it's probably just so much liquid flowing through here that by the time it gets to here, it starts to boil off and we get 2 degrees superheat. That means that this coil is also flooded, which again, this one's stacking all the charge from the system, this one being flooded. These are two key indications that something is wrong and that the four-way valves should be checked. Now, it doesn't help that this series of equipment has notable issues where they found that the four-way valves 99% of the time usually have failed on this type of equipment. And this is a, what is it? This is an R2 K series. Yes. And so much so, let's take it back here. You can rewind the tape if you want to watch how we got to that diagnosis, that there's actually testing procedures, right? So much so that here are the testing procedures for four-way valves. Now, I'm not sure exactly who made this, but it's actually really good. You'll see here they took a four-way valve cutaway and they did a few things. Now, this is the R2 Gen Series 21S4, which is our valve, right? If I go back to the MNet program, right, I can show you, right? This is it, 21S4B and 21S4A. Same four-way valve, just in different positions. Same thing on the submodule. Now, we think that the 21S4B four-way valve has failed. And so how do we confirm that? Well, this is how you confirm that. We take the four-way valve, right? And knowing that it's in cooling, it does this. Now, orientation matters. Am I looking at it from the left? Am I looking at it from the right? Obviously, you're going to want to take temperature measurements across the four-way valve itself or use a magnet. But here's the thing. If we know that it goes in cooling, hot gas goes to the left. Middle is always suction at the bottom here, right? And then this is heating, right? Hot gas is always going to the outside, whether it's left or right, and its middle is always suction in this orientation. How do we use a tape measure to figure this out? Well, here's the thing. We know that the slide on this is made of basically steel. Steel is magnetic. The brass body of this valve is non-magnetic. And so what do? Well, you apply a magnet to the outside of this to actually see where the position is at. Genius. I wish I would have thought of this. I didn't. So seeing here that if I put a magnet on one side, this means that the valve is shifted to the left and it's in cooling mode. If the magnet sticks to the right-hand side like this, then we know that it's in heating mode. And so I can determine where it's shifted and where it got stuck in that four-way valve. So here's a live system, right? This is units in cooling, valve is in cooling, and we can see it all the way to the far right here. This is the same thing, but the other valve, right, is stuck in heating mode. And why is that? Because the magnet doesn't get stuck until this portion of the valve, which again should be all the way to the right. This is how we determine, using a magnet, whether it's stuck on a four-way valve like this. Now, let's keep rolling through it, and let's go even to another presentation that I wish I created, but I didn't. This one goes out to Steve Cook. Thank you for sharing this one. N generation R2 four-way valve diagnosis and replacement. This is your module. This is your four-way valves, right? There we go. Make me a little bit smaller there. Right, here's our model number. It matches up to mine. Look at that. He's even got his name down here at the bottom. All the material list, the parts, the pieces, what it looks like, what it's doing, what sensors to check to find that. Now, we did look at TH4, right? Discharge temp. You can look at the indoor thermistors to see how the actual refrigerant is flowing. If it is flowing, or is it stalled? Has it not gone anywhere? Is it recirculating like it is in the submodule like we saw, right? Where are the four-way valves at? What does that look like? All those things to where we're actually going to confirm now by measuring temperature and using maybe a Corel magnet or something like that on the four-way valve to determine is it stuck and what that looks like. And this goes all the way into the replacement of the valve, which again, kudos to Steve for putting this together because it is a long list of things to cut out, disconnect, how to cut it, where to disconnect, how to put it back together, what order, and how to get it all reassembled. Do a nice little presentation here. So if you want a copy of this presentation, feel free to reach out. I would love to share it with you guys as it was shared with me. But this piece of equipment has a failed four-way valve on the submodule. And not just any four-way valve, but the lower four-way valve 21S4B. Not A, but B. This is how we determine it. So hopefully you guys enjoy this. And yes, I will have a lot more Mitsubishi data. And if you have any other pieces of equipment that you'd like me to look at, go through, show you the service data, come to a conclusion here with you, and how to troubleshoot using, programs like this, send it my way, and I will definitely take a crack at it. So see you guys on the next one.